All right, let's get started. Welcome to the May 2024 OpenZFS Leadership Meeting. I saw quite a few things on the agenda. Looks like the first one, Alexander, you want to talk about memory pressure, multi-gen RU?
Yes, I'd like to talk about it, or more like bring discussion about it, to share some experiences and ideas. It started a few weeks ago when we upgraded TrueNAS scale to Linux 6.6 LTS, and with ZFS 2.3 now 2.4 with increased arc size to maximum, practically from 2.3. So from one point we are practically getting to bleeding edge, but from another, with 2.3 getting close to release, that's where we end up altogether very, very soon. That's why I'd like people to be aware of our findings or our pain, and maybe together we can find something better than what we have. So problem started originally when people started reporting slowdowns of web interface and user space processes, but looking closer appeared that systems started to swap in enough as soon as they have swap. Some investigation brought me to the new code that was introduced for quite a while, but it gradually increased in size. It's called multi-gen LRU. I found some pieces of it in 6.1 kernel, but in 6.6 it got bigger and enabled by default. So its idea, as I understood, among other things, is its goal is to reduce number of iterations required to evict memory from page cache, buffers from page cache and other sources faster than right now it's done in multiple iterations. Ideally, it should be done in one iteration. The problem, it first jumps into page cache. It looks how much there can be evicted according to that multiple generations it tracks. I guess it's more complicated logic to estimate active dataset size. I haven't looked too much into that code. It's quite a lot. It wasn't exactly my goal. But seems like it's what it does. It estimates size, and then instead of gradually increasing pressure from 12, which is one of 4K, 11, one of 2K, and so gradually increasing pressure and putting on both on page cache and shrinker subsystem, which effectively where ZFS receives its back pressure. Instead of pushing both page cache and ZFS same time and gradually getting up to the decent point, it calculates pressure in one go in the function. Call it, if somebody care to look, set initial priority. It just sets priority to whatever level. It could be pretty high, and then drops significant part of page cache, in which process it activates swap also. That's what actually we saw as our performance problem on TrueNAS. But then it applies exactly the same pressure, which is an insane value. I saw like 2, 3, 1, even 0. 0 means practically drop everything you have. It's close to out of memory level. So if not the limit of eviction we have in ZFS, ZFS would just drop all of its memory, all of its arc, or at least I saw it dropping like half or quarter, something like that of arc. But it happens we first doing swapping, and then we drop in arc after we already swapped out something. So it seems wrong from any possible direction. I reported that issue to the author of the multi-gen LRU patches, and he confirmed that such interaction with shrinker is wrong, but that's only in a part of setting priority to shrinker is wrong. But even if its priority would be lower, it would be nicer to ZFS, but still wouldn't help with the swap. At least it didn't help for me when I tried the patch. So the problem, it seems like generally it doesn't look like it's these days it's very realistic to live with ZFS and page cache with last trying to shrink all it wants in one go, because it doesn't know anything about ZFS and ZFS actually lies about what can it free. So it seems like a endless loop. ZFS lies to kernel. Kernel doesn't even look on ZFS, even if it's lies or not, but then tells ZFS to free some insane memory, which ZFS also doesn't free. So perfect situation. So at this point, we work around this issue of, primarily by disabling that multi-channel RU. Fortunately, there is a sysctl or sysfs knob for that, plus also disable swap and reduce its swappiness, just attack it from all possible sides. Altogether, it seems like it's okay for us for now, but it doesn't solve problem for others, and it won't work as soon as new code will become default in mainstream Linux. So that's sad news, and that's point where I would like to hear any ideas whether anybody hit that point or have any ideas. I'm glad, Matt, you're here, since you was one of the last who touched that code on the FS side, and I guess you already hit some issues in that area, at least from a point where ZFS ignores requests from kernel. Even so, I suppose you hit bugs that are already fixed for quite a while, for many years actually, in modern kernels. But yeah.
That was quite a while ago. I have to refresh my memory. But it does sound familiar. It sounds like the main well, there's two, you're describing kind of two big problems. One is changes, new problems. The priority that it's telling the shrinker is like too intense, which is something that in theory we can work around by kind of like knowing, oh, we're compiling against this kernel version, and so yeah, it says to evict with priority 1, but that's going to mean only like an eighth instead of like half or whatever. But the more serious, the problem that's harder to work around is that the logic is now like kick stuff out of the page cache, push stuff into swap, and then notifies the FS via the shrinker to do anything. And in fact, most of the memory is probably sitting in the ARC a lot of the time, especially because now we allow ZFS to use more or less all the memory instead of only half of it. Is that like a good summary of the situation?
Yeah, pretty much. So I guess that code in page cache was never tuned to situation when it is minority of consumers. We have some reports from users who had different thresholds set, above 50, but somebody tried 85 and reported it's okay. Others reported that 85 still not okay. It's not exactly clear if we have any safe level where page cache code would be reasonable, or at least
you're talking about limiting the ARC to like 85% of memory.
Yeah. But again, somebody report 85 is okay, other report no, it's not okay. At 50 maybe it was okay, but it's hard to say, because 50 we also use it with previous kernel without multi-channel RU. So we change it to things same time, and now like what is bigger cause, what is secondary cause, or is it both of them influence? I suspect the second.
I mean, it seems likely that the change in the kernel is kind of the primary thing, and then the change in the amount of memory that ZFS uses is exacerbating the situation. Given that the change in the kernel is a change in the logic versus the ZFS change is just a matter of degree.
Yeah, I was. You mentioned analyzing priorities that kernel requests for us, and it would be nice, but problem that shrinker doesn't receive priority directly. I don't know why it's made that way, but it's written in a way to provide shrinkers the least possible information possible. So what it does, it actually first asks shrinker how much can you free, and then it start requesting shrinks in 128 pages or 64 pages granularity.
Yeah.
So give me half megabyte, and it can do that in a loop for gigabytes.
Yeah.
So I was thinking, no, it's feels ugly to me, but I was thinking maybe we could just do some counter, per CPU counter, and if some, or per thread counter, whatever, if some thread first requested, how much do you have, we reset counter to 0, and each time it asks us, give some more, we increase, okay, it asked more than that. If it asked more than Y, that probably is insane. But again, by that time, we may already free quite a lot by the time we detect it is insane.
Yeah.
So it's, I don't know why the code is written in a way. It's possible to actually control granularity, but if I actually first try to increase it, but it's written in a way that if you set granularity too high, that my goal is to set it to int max or whatever, just to ignore granularity. But after that, it's written in a way that it will not request anything at all. Just
Yeah, I mean, I remember when I worked on this several years back, I was kind of like, I had both I had the kernel code and the ZFS code, and I'm looking at like none of this makes any sense, but let me see kind of how do they interact, and then changing ZFS to like do the right thing given the calls that it's getting, by looking at their kernel code. But obviously that depends on the specific version of the kernel I was looking at, which seems like now has been changed. So it's not too surprising that it doesn't work great. And maybe it would be possible to do something similar, but like you said, a lot of information is getting dropped in that interface, so it's hard to know what to do.
Well, yeah, I shared with Brian last week, and he told he's not aware about that issue, but he thought his answer was maybe we could integrate with page cache somehow, but I honestly don't know how, especially Science page cache after that would like to handle eviction by itself, implement some LRU by itself, while the FS has its own mechanisms for that. It would mean...
Yeah, I mean, that would be a big undertaking.
Yeah. And without that question, what can we do? I suppose right now the code is living mostly because GFS has its own mechanism to keep free memory. But then I suppose it may be a problem, and we see also some problems like that when memory getting fragmented. Kernel should increase pressure on all subsystem and free more until the memory is sequential and good and reusable. But the problem, if ZFS will just live on its own, it doesn't see that fragmentation, and if it ignores requests from kernel, then kernel will quickly give up on getting contiguous memory, and you'll get allocation problems. Yep. From subsystems that care about sequential allocation.
Yeah, I mean, those, when I looked at it several years ago, those were the biggest problems, and those were like the fragmentation stuff was kind of the whole reason why we need to have the shrinker paying attention, because like you said, otherwise we could just notice how much free memory there is and like adjust it dynamically. So the only reason we really need to integrate with the shrinker is the fragmentation, and then like if you have one big process that starts up and is like, now I would like 100 gigs of RAM, then it calls into the shrinker to tell us before killing that process. But it seems hard. I mean, even with the changes that we made, we still kind of solved the problem also by just going and looking at the things that actually needed multiple page allocations and tweaking those so that it happened less often, which is not a great solution.
Looking at the code, yes.
I was wondering, like, when we register for the shrinker when the module gets loaded or whatever, right? Is there some way to tell it that it should call ZFS kind of at the same time as it calls, or right after it calls the page cache shrinker before it goes to trying to push stuff into swap? Or we could just say, call us sooner?
Page cache doesn't use shrinker. It's separate code.
Okay.
It's first does page cache explicitly and then goes to all the shrinkers. No, there may be some hierarchy of calls, but it's based on CPU groups.
Mhm.
Actually, right now, thought maybe we could fake some that we support CPU groups and do something about that. That actually interesting question. Maybe somehow that way we could be called earlier than everybody else. No, then, but right now we have no idea about neither CPU groups, no NUMA, nor anything. So we may likely be called somewhere as last resort.
Okay.
One more, speaking about fragmentation, I've noticed one more difference at least between FreeBSD and Linux. I haven't experimented too much about it, but wonder if anybody else did. On FreeBSD, ZFS always allocates individual pages at 4 kilobyte granularity. That means that if kernel memory is fragmented, ZFS will collect the worst possible pages, hopefully leaving all the contiguous pages to anybody who may need them. While ZFS on Linux seems to be greedy, and it always tries to allocate pages of maximum size, maximum of power of 2 size through body allocator. So it tries to like, what's the maximum there? 32 kilobyte more, it's actually bigger. No, biggest possible than half size, half size, half size. At the end, it will consume all the big allocations, and only after that it will drop to smaller ones. We have tunable to control maximum allocation sizes, but I wonder if anybody has experience for that in the real world environment, whether reducing ZFS to smaller allocation help other kernel subsystem to allocate more contiguous pages. Because potentially if ZFS would consume bad pages, maybe then page cache wouldn't need to be shrunk without so much to defragment memory, which may be hopeless if ZFS already consumed most of memory.
I haven't looked at that, but it's a good idea to try reduce it down to like start with only 4 pages or 2 pages, or maybe even just only do single pages, and see if that kind of reduces the fragmentation pressure on the rest of the system.
Well, yeah, I tried briefly to look on that, to try and experiment, but I was doing that while looking on swapping problems, so wasn't exactly focused on that. Swapping problem has seen different, or mostly different causes. But that's, I tried to look whether ZFS can get any idea what's current kernel memory fragmentation is, because if system just freshly booted, it's perfectly fine allocate huge chunks because there are plenty of them, why not allocate them? But while the system is getting fragmented, maybe after ZFS will start first receiving allocation problems, then it should remember then that never try to allocate bigger than half of previously failed or something like that. But I tried to look on any KPIs present that could provide the information, but I haven't found anything. That very few methods are public there, and some even GPL. So I don't know how else to do it rather than looking on previous allocation failures.
Yeah, I don't remember seeing anything along those lines. I think you can get it from /sys or /proc, but that would be pretty gross to have the ZFS kernel like reading, opening proc meminfo and then like parsing the ASCII text. But yeah, like that's what we have done, like for system monitoring stuff and whatnot, just cat that stuff from /proc every so often so that we can at least tell if it was bad at the time that something bad happened. If fragmentation was bad when, some bad system effect happened.
We could look on how much memory is used in general. If there half of memory is free, then likely there should be a lot more contiguous, but that's not always true potentially.
Yeah.
If every second page is free, it's already 50%.
Well, the first experiment could be just saying like, hey, what if we just always do single page allocations? Does that actually help? If so, then maybe we can find some heuristic to like put the system into that mode, not all the time, but some of the time, you know, like if it's more than if there's less than 25% free memory, then do single page allocations. I don't know. Like it's a hack, but maybe it's enough to relieve some of that pressure.
Okay, thanks everybody. Well, I understand that's difficult to discuss live without preparation, but I'd like to bring attention to that. And if anybody will have any ideas, please ping me. So as I've told, for now we work around that, but who knows how long that workaround survive? Maybe till the end of the year when next LTS is out, and we are back in square one, but without solution.
Yeah. Other folks have any ideas or input or share this concern or not?
Definitely share the concern.
Yeah, me too.
Well, be interested to help because we're investigating a performance issue on someone using a 6.8 kernel, and I wondered if it was maybe the same thing, but it seems they already have that option off.
Did they found that kernel option to disable it or some? Because at least in Debian, it's enabled by default. I haven't looked what it is.
This is Debian as well. It's just I think I had the right thing under /sys, and it was set to 0, not 1.
Interesting. No, we said it through the kernel parameter is configurable through there too.
Well, can you share which parameter it is? And maybe I can reboot the box and double check because it seems unlikely it would make no difference. So.
Yeah, just I need to find.
Thank you.
All right. The next item on the agenda, Paul, hierarchical rate limits. It's exciting. Did you want to?
He was here and had his video on, and now his video is off.
Oh yeah, maybe he stepped away.
Oh, he's back.
Sorry, yeah. I'm here. Can you guys hear me?
Yep.
Okay. So just a quick update. I put rate limits for review. Those are hierarchical limits, just like quotas, basically. So few changes since the PR was published. I decided to limit block cloning the same way as it would be read and write. Somebody was asking about that, and at least on FreeBSD there is a single interface to do block cloning, copy file range, and the application doesn't really know what is used underneath. So and those limits are basically they should be visible from the application point of view, not from the storage point of view. So all the savings and inflations, if exist, those are on the storage side. So for the application, it should be stable. Like the application should see the same limits all the time. So I added this to block cloning. Also, on FreeBSD, there was a small issue when I started to write tests. FreeBSD, when this is for operations limits. So FreeBSD, when it creates a file, this was accounted as a write operation. But we also create VM backing object for the file, and when the function was given 0 size, it was always asking for file size. So even though we know the file was just created and the size is 0, the function will ask for the file size, so it was charged also for read operation. So I have a patch for FreeBSD to fix that. So file creation should be just one operation, and that's it. Also, now that block cloning is limited, but also block cloning can be slow in some cases, especially when you have very small record size and very large file. There is another PR I published that allows to interrupt the block cloning with a signal. So on FreeBSD, this is useful because tools like CP can report progress. So it sends sig info to the process, and we can interrupt copy file range this way and report progress. And copy file range can easily continue. Yeah, it just works. So I would appreciate if somebody could take a look at the PR and let me know what do you guys think. Thank you.
Yeah. I also saw you mention that it applies to ZFS send and receive, the rate
Yes.
limiting. But you said you were limiting it in the VFS. How are you doing it separately for send receive?
Yes, for send and receive, it's done separately.
Okay.
Yeah.
I was wondering because we were looking at the per dataset K-stats, and we have a customer that wants to account for send and receive in those per dataset K-stats, so they can, blame the dataset that's using the read and write bandwidth. And the fact that currently those are done at the VFS layer for file systems and then separately for ZVols. But to do it at send receive, we have to do it in the DMU. And I was wondering if you had found some clever solution.
The API for rate limits is just really simple. You just put one call in place. So so ZFS send and receive are handled separately.
Okay.
The same like ZVols.
As well. Yep. Because I was wondering, looking, I guess not really related to what you're talking about, but currently we hang the kstat struct off of the ZFS VFS object and then separately off the ZVol object, and both of them have a pointer back to the obj set. And I wondered if it makes sense to move that kstat to just always be in the obj set.
Yeah,
so
that's
that it
what
would
I
apply
use
to. Yeah, so it would apply to the VFS, the ZVol, and the DMU use cases.
That's what I use for. I use an object set, object set for rate limits API. So yeah, so it works for file systems and ZVols. And also, just maybe I will mention. So I added quite a lot of tests. So the tests take over 1 hour to run, but for the common run file, I'm just picking a random test to run, which should be a few minutes at most. But those tests can be, we will see in practice, but they can be a bit fragile because I basically measure time. So if the test machine is slow for some reason, I may measure more time than I expect, and the test will fail. So I only give most of the tests are like few seconds, like 6 to 10 seconds, and I only accept times plus minus 1 second. So on virtual machine somewhere, when there is slow storage or slow machine, I guess it might be unstable, but we will see. That's it from me. Thank you.
All right, thanks, Powell. Next looks like a bunch of PRs from Alan and Clara, folks.
Yeah, the first one is pretty simple. We've been chasing in FreeBSD for a while. This assertion that fires usually during shutdown, or basically when you're trying to unload the ZFS module, that it would find memory still referenced by the ARC when the ARC should have been completely evicted. And Mark Johnston from our team chased that down, and it looks like, Alexander, you had an idea of what to do to fix it?
No, yeah, as I've written there, once I added last night arc free, whatever, how that function was, just practically freed that buffer. Seems like leak went away and the FS unload or reboots succeeds. I was going to check whether anything else may need to be done besides that arc boot destroy call. But otherwise, I haven't got to it yet today, as promised, but I'm going to look, but it may be one line patch.
Okay, great. And then separately, next week at BSDCon, Mark's going to try to find time to formalize the tool he wrote to debug this, where reference counting could optionally maybe, like, protected by the debug flag, include the stack of who took the reference beyond just the current kind of tag thing we do, so that when we find a leaked reference, we know, what stack created the reference. I think that could be useful for everyone.
Yeah, that's what we had back in the Lumos days.
Yeah, but he's got it working on FreeBSD, and I think give him a couple of pointers on how to make it work for Linux, and maybe we'll be able to have something that way.
Cool, that'd be great.
And then the next couple on dedupe, the dedupe quota and dedupe preload. Alexander's done his reviews and we've responded to those, and Brian Bellendorf did his as well. But if anybody else could take a look at those and just give them a look over, that'd be great. And then those two can get merged and we can rebase and get the next chunk of them up. And then towards that, the fast dedupe PR that has the bulk of the changes, only Alexander's had a chance to look at that so far. So if other people could start looking at that, we'd like to continue to push that forward. It's been a little while now. I think we posted these originally in February.
Yeah, I'd really like to support that too. If we personally at IX would like to have, as I previously asked, to have 2.3 branches somewhere at the end of Q2, so that we could go with our release cycle. And for that, we'd really like to have this integrated. We're already running nightlies from ZFS master in preparation to that, so we are targeted to using 2.3 in next release, but for that it has to happen in next month or two. Otherwise we'll be in an uncomfortable situation. So I did look on all the previous patches except the fast dedupe. Fast dedupe I think I saw only in previous incarnation before it was published. And I had a few comments there, but I haven't looked whether it was all of them were handled or not.
They should have been, I think. And then that one's been up for a while. The one new one that will come up soon is the dedupe prune, which didn't go up in February because there were some conflicts with a bunch of the other stuff. But now that we've landed the first couple of these patches and rebased everything, we expect to have the last dedupe PR up this month, or this week even. And that's the one that will actually let you evict stuff from the DDT when it gets close to full, and that makes the dedupe quota feature much more useful. Because it means you don't stop deduping, you just find older stuff to remove.
So on 2.3, I know Brian's not here. Tony Hutter, do you have any thoughts or context on the timeline for 2.3?
No, nothing specific.
All right, we'll have to.
As I've told, I asked Brian about it, and we kind of agree that it should be doable by the end of Q2, but it was discussed in the winter. So time is going, but I still hope we'll stay in line it will be just a year science branching of 2.2. So 2.2 we over delayed, but I would like to not do the same for 2.3.
Yeah.
At least for us, it would mess up things. So
Yeah, sounds like a good plan.
Yeah, and we've been doing extra general testing with Z-test and Z-Lupin. Found a couple of things and working through them. Like I saw Brady's not here right now, but he found I think 20 different crashes by running Z-test on a 128 core machine for a whole week, and has been triaging those, and hopefully we can get a bunch of just quality improvements as part of 2.3 as well, and have more confidence that the changes we're making are not causing any problems.
Cool, that's great. Better testing is always better.
Yep.
Do you want to highlight any of these other ones?
And then I guess the other ones were Rob on our team's been working on more stats and stuff to be able to figure out why NVMe isn't going as fast as we think it should. Especially, we've been playing with one machine here that's got a bunch of Micron 9400s in it, which the spec sheet says can do 1.6 million IOPS each, and FIO agrees they can do 1.6 million IOPS each. And you put them in ZFS and it can do 400 IOPS or 400,000 IOPS, and that's it. Interestingly, as you add more VDEVs, the performance doesn't go up, which seems the problem is definitely not the disk in that case. So digging into that and figuring out what's the problem.
Yeah, that may not be in the VDEV layer. Like there's so many layers above that.
Yep.
If it's mean you're driving like a workload from userland, 400,000 is pretty good from what I've seen in my testing. It's been hard for us to even hit 200,000. Like say, you're talking about reads,
Yeah,
reads,
random reads.
calls, random reads going to the actual disk.
And the only way we got to high numbers is either a lot of threads with PvSync or the IOU ring on Linux. If you're using any of the like AIO versions, you're only getting like 200,000 IOPS.
Yeah, and then are you using multiple files, multiple file systems?
Separate file for each thread. We tried splitting it up. So instead of 64 files in one data set, we spread them across different data sets, but that didn't make any difference.
Okay. Yeah,
Because we wondered about some of those locks, and it wasn't.
Yeah, I would look at like the CPU flame graphs, and that may help to highlight locks.
Yeah, a lot of VDEV-Q lock and some other stuff, but nothing really standing out about why the performance doesn't scale as we look at more separate VDEVs. Because if it's the VDEV-Q lock, then a separate VDEV has a separate VDEV-Q lock. Why does the performance stay the same?
Yeah, there may be either locks higher up.
Because we also tried the direct IO patches, but because we're doing 4K records, that didn't seem to make any difference there either. Because I also wondered, is the ARC to blame for the bottleneck here? But it doesn't seem to be either.
Yeah, it could be because you can get into situations where the ARC eviction can't keep up. So
right, we have that problem for a different customer. We have patches, which I'll post soon. We have multi-threaded ARC eviction working.
Okay. And
it takes like the time to export a pool with a 0.5 terabyte of ARC from like 7 minutes to 2 minutes. And then separately, Don's, I think it's already committed. Don's got the parallel export. So if you have multiple pools, you can export them all at once. But we also revived and finished a patch from Illumos that allows the freeing of the ARC to be done in the background after the pool is exported, so that you don't have to wait for it, especially doing HA failover or something. Yeah, I thought Matt would give a thumbs up to that.
Yeah, you may want to look at like both the arc evict thread, if you have
But
it.
so in this case, we have
Are you using those patches for the?
primary cache equals metadata, so the arc is not full.
Yeah, and I think that in that case the pages are thrown out of the arc by the thread that like bumps the ref count down to 0.
Mhm.
And I think that that's true of the debuff cache as well. If you weren't doing that, then I would say look at the arc evict and also debuff evict threads,
Mhm.
because those are each just one thread and can become a bottleneck.
Yes, that reminds me, we have another patch for debuff evict. The way it works is it has an outer loop for is the debuff overflowing, and then it has another one where it walks the LRU from the bottom, trying to try locking each item until it finds one it can evict, and then it returns to the outer loop and comes back in and does one at a time. And we made it just, evict 100 items at a time as you're walking the list, so you don't just walk over the same already locked items over and over and over again. And it seems to make a pretty big difference.
Cool.
But yeah, so we have a bunch of pull requests we got to actually finalize and get posted for you guys too.
All right. Other topics for today's meeting? All right. If not, then we will see you all in 4 weeks.
Okay. Thanks, everyone.
See ya.